So we're going to continue our discussion on transformations today. Yesterday we talked about translations. Remember, that was just your slide. You slid that shape to the left, to the right, up or down on the coordinate plane. Today it's all about reflections. A reflection is a transformation that flips a figure across the x or the y axis. It is a mirror image. So here is an example of that arrow being flipped over. Which axis runs up or down? The y-axis. So this would be like this arrow being flipped over the y-axis. A reflection is flipped over a line. After a shape is reflected, it looks like a mirror image of itself. And we talked about, like, if you're looking in a mirror and you have writing on your shirt, though your figure looks the same, the shape looks the same, any writing that's on your shirt is going to be flipped because it's a reflection of what is being shown. So after a shape is reflected, it looks like a mirror image of itself. And again, it's flipped over a line. So this kind of looks like a Pac-Man shape. A translation would take the same shape in the same direction and just slide it to the left or the right. A reflection is like taking that shape, and it's almost like turning the page in a book. It is the same shape, but kind of opposite the direction it would be as the original would be. Remember, it's the same, but it's backwards. So that's the biggest difference between a reflection and a translation. It's like it's the same shape, but it's backwards. And notice that every point on this, like Pac-Man guy, is the same distance from that line of reflection. So the opening of his mouth is as far on the left side as it is on the right side. They're the same distance away from that line. If this was like a sheet of paper and I was to fold it at that line, those shapes would fall right on top of each other. Like if you're looking in the mirror, you're the same distance away from that mirror as you would be kind of from the point of reflection. Remember, it is the same, but it is backwards. So that's something important to jot down. I know I didn't give you a specific place for that, but jot that down somewhere in your notes. Just somewhere in your notes. Did you get this down? Did you get this down in the back? Okay, jot this down. There's just a few words, like 2 words. You can write down 2 words. The line that a shape is flipped over is called the line of reflection. And for our purposes, that line of reflection is going to be either the x-axis or the y-axis. So far, we've looked at some examples of what a shape would look like reflected over the y-axis. Can anyone take a guess what it would look like if it was reflected over the x-axis? Remember, the x-axis is the one that goes left to right. Yes, ma'am? Janaya. What would it look like? Be upside down. Just gave you a shout out on the World Wide Web. So think of like a book, a page in a book. Here's my notebook, my spiral. If this is my line of reflection, and there's a shape on this side, it's going to end up over here on this side. It's going to move from left to right. But if my line, so this would be like the y-axis. If my line of reflection was the x-axis, the one that runs left to right, what was here is now going to be down here. So that's the difference in what the reflection looks like. If it's over the x-axis, it's going to be up top, start up top, end up on the bottom. If it's a reflection over the y-axis, it's going to start on the left, end up on the right. Notice the shapes are exactly the same distance from the line of reflection on both sides. So, speaking of reflections over the x and the y-axis, I'd like for you to recreate those shapes as best you can. Reflection across the y-axis means the x value changes sign. So over here, we don't have to know exactly what the coordinates are, but what we do know is that in this space, all of your x-axes are positive or negative. Who can tell me? Can you see the little red dot? All of our x values are positive or negative towards the right of the origin. Are they positive or negative, guys? Positive. Are the x values positive or negative to the left of the origin? They're negative over here. So here the x value changes. Down here, this would be, go ahead and write this, a reflection over the y-axis. Good job. And it changes the x value. Changes x. Changes x. Down here, we're reflecting over the x value. Good job, Kira, giving you a shout out on the World Wide Web. And the y value changes. It started out positive up here over the origin. It's going to end up negative down here. So our y value changes. It changes y. But notice every point is the same distance from our line of reflection. Every point on the P is the same distance from our line of reflection. So now we're going to look at some examples. Since we're reflecting across the x-axis, our y values are going to change signs. And we want you to reflect these 3 points across the x-axis. So remember, our x-axis is the one that runs left to right. So our y value, which was positive on top of it, is going to be negative below it. Just the y. So I'm going to circle all of our y values. What's going to happen to all of our y values? They're all positive. What's going to happen to them? They're all up here. They're all going to become negative. Hit pause and give you some time to figure out the new points. The x values are going to stay the same. So notice that all of the x values stay the same. And the y values, because you're flipping over the x, what was positive is now going to become negative. So all of these positive values become their negative opposites. The way I kind of remember it is kind of like if you're friends or if you're family, you look out for each other. The x-axis looks out for the x values. So if you're flipping it over the x-axis, all the x's, they're protected. They get to stay the same. They're part of the group. They're part of the club. The reverse is true with the y-axis and the y-coordinates. If you're flipping it over the y-axis, then the y values are safe. They're protected. They don't have to change. The x values are the ones that have to change. So x-axis looks out for the x-coordinates. They all get to stay the same. The y values have to become their opposites. So you try. You've got 2 examples and 2 coordinate planes to practice this with. So take a few moments and do those 2 examples while I pass out the glue sticks so that you can get these in your notes.